Today we're going to be going over the 25s. We're going to be doing a lab, so I'll be giving some lab information. You're going to need your cover and your 25s today. The Chatelain's principle, you're going to write this on your unit pack cover. This is where we're going to be using pretty much the whole unit. It starts off with the words, if a chemical system is at equilibrium and it experiences a stress, then the reaction will shift to lessen the effect of that stress. And that's kind of key to everything that we're going to be doing in this unit. Feel free to pause the video at any point in time so you can have the time to write down what you need to write down. So again, do not be afraid to pause the video. So we're going to name the following compounds. Pause the video, I'd like you to do that. So if we do look at these are both non-metals, and there's two nitrogens. So how we say two nitrogens is di, so dinitrogen. And there's four oxygens, and we say four with the word tetra. And then oxygen turns into oxide. So that is the name of that one. This one right here, there's one nitrogen, but we do not put mono on the first element, so it's just nitrogen. And there's two oxygens, so we call it dioxide. So those are our two names that we have. So we want to balance this equation. So N's and O's. On this side we have 2. On this side we have 4. On this side we have 1 nitrogen. On this side we have 2. So if I put a 2 there, now I have 2 nitrogens and I have 4 oxygens, and it is balanced. So that is balancing the equation. This gas is brownish in color. This gas is colorless. So we're going to have 2 test tubes, and they're both going to have nitrogen dioxide and dinitrogen tetroxide in them. So both gases will be in there at the same time. So we'll expect the test tube to be kind of brownish in color. One test tube is going to be subjected to an increase in energy, which would be our hot water. One's going to have a decrease in energy, which is going to be our cold water. NO2 is our brownish gas, and N2O4 is a colorless gas. And you'd be answering your questions based on the results that you get from the lab. So when the gas mixture is heated, did the color of the gas become lighter or darker? And the answer for this one would be darker. So the test tube that we put into some hot water, it became darker in color. That is the answer to that one. Which gas, nitrogen dioxide or dinitrogen tetroxide, has the color of the heated gas? Well, this would be the answer right here. When we heated it, it did become more brown in color or darker in color. The production of gas is favored by the heating, or increasing energy. So when we say favor, we mean a bigger arrow, and this would be our answer. When we heat it up, it does in fact get more brown in color. So nitrogen dioxide is favored when we increase the energy. Which way did the reaction shift when energy was added? It shifted that direction or towards the products. How do we know that? We got more of the nitrogen dioxide, which is brownish in color. The test tube got darker in color. When the gas mixture is cooled, did the color of the gas become lighter or darker? When we cooled the test tube, it did become lighter in color. Whoop, went the wrong way. Which gas, NO2 or N2O4, has the color of the cooled gas? Well, if it became lighter in color, we must have more of the colorless gas forming in there. The production of which gas is favored by removing energy? Well, this gas is favored when we remove energy because it became lighter in color. Which way did the reaction shift when energy was removed from the system? It shifted this direction towards the reactants. when we remove energy from the system. State the Chatelier's principle. Hopefully you can do this out of your head. If not, you're going to have to look at your cover. Of course, you'll know I will show it to you. If a chemical system at equilibrium experiences a stress, then the reaction will shift to lessen the effect of the stress. Now, when we say shift, we mean these arrows that are between the products and reactants. Going on to the back side. So, based on the Chatelier's principle, use the data you collected from the front side and the Chatelier's principle to predict where the energy term is located for the reaction. Write energy or kilojoules on that side. So, when we heat this, when we heat up the test tubes, we shift this way and we become darker. When we cool the test tubes, it shifts this way, and we know that because it became lighter in color, less dark. So which side do you think the energy term would be on? You should make a guess at this point in time. Kilojoules ends up being on this side, or energy ends up being on this side. So when we heat this reaction, and I might be foreshadowing the next couple questions, when we add energy, when energy goes up, it's going to shift to get rid of the energy. So these two would react together. Some of the kilojoules or energy would be consumed, and we would make more of this NO2, nitrogen dioxide, and it would become darker in color. That's one piece of evidence to say kilojoules is on that side. Another piece of evidence would be when we cooled it. So when our energy, gotta learn how to spell energy. When our energy is reduced or removed, the reaction shifted to produce more energy, and it became more colorless. So those are pieces of evidence that support that kilojoules are over on the reactant side. So if a stress like decreased energy is placed on the above system, which way should the reaction shift? So if kilojoules are over here and the energy is reduced, energy goes down, it's going to shift to produce more energy, and it becomes more colorless. If we somehow are able to add some N2O4, so if we increase some N2O4 in this test tube, which way will the reaction shift? Well, the Chatelier's principle says anytime you add a stress, the reaction is going to shift to reduce the stress. So if I'm adding some N2O4, it's going to shift to get rid of some N2O4, and it would become darker or more brown in color. So it would shift towards the product side. I would really like you to be answering these questions on your own before I go over them. If we somehow were able to add some NO2, some NO2 is added. So NO2 increases, the reaction is going to shift to use up some of the NO2. So it would shift this way, and we would expect the whole solution to become more colorless. So shift towards the reactant side. If we somehow were able to remove some N2O4, so N2O4, its amount decreases, the reaction should shift to try to produce some more N2O4. So it would shift towards the reactant side. If you're somehow able to remove some NO2, so NO2 was removed, it would shift towards the product side to try to make some more NO2. Which has a higher pressure in a confined space, 2 moles of gas or 1 mole of gas? Please pause the video and try to answer these questions ahead of time. So pressure is defined by how often gas molecules hit the insides of the container. So if we have 1 gas molecule here, but we have 2 of them over here, This one should hit the sides of the container twice as often. So this one should have twice the pressure of this one because there's only one molecule of gas. So which has a higher pressure? That would be 2 moles of gas would have a higher pressure. So in this instance, this would have a higher pressure. So at this moment, take heat and energy out of your thoughts. If we pushed a rubber stopper halfway down in the test tube, so again, this experiment that we did, we used some test tubes. This is the rubber stopper on top. It's saying if we took that rubber stopper and we squished it down, so in other words, we made the pressure go up, which way would it shift? Well, if pressure increases and this side over here, since it's only got 1 mole of gas, is at lower pressure, if we increase the pressure, the reaction would shift to try to reduce the pressure, and it would shift that way. So shift towards the reactants. And we would expect it to become lighter brown or more colorless in that instance. How can you find out if the gases in your test tube are more or less dense than air without actually removing the stopper? To do this, I'm just going to show you the answers to it. So we would look and we would realize that air is a mixture of gases. Air is 79% nitrogen, 21% oxygen. So you can calculate a weighted average of those. So 79% nitrogen, so 79% of 28.02, that is the molar mass of nitrogen. And oxygen is 20.95%. Our air is 20.95% oxygen. That's the molar mass of oxygen, and that is the molar mass of air. If we look at the test tubes, we have NO2 in there, which is 46.01 grams per mole. And if we look at that, that is heavier than what the molar mass of air is. So if we were to open our test tubes, we would expect the gases to come rolling out and hit the floor. And that is it for the 25s. Have a good day.